Good morning to all. In the process equipment design, there is a mechanical design of distillation column should be discussed. Mechanical design of distillation column. Distillation is method of separating components of solutions. We are relatively volatile. Distillation is carried out either in tray tower or pack tower. Normally, for a vacuum operation or when a tower diameter is required very small, in other words, it is less than or equal to 6 inch, or for a highly corrosive system like a separation of methyl iodide and acetic acid, pack towers are used. Otherwise, for a normal and high pressure, for a handling higher value of liquid volume ratio, tray tower are used. Generally, the distillation tower are mainly two types, which is used in industry. That is a tray tower or a pack tower. નોર્મલી વેક્યુમ ઓપરેશન હોય અથવા તો જ્યારે ટાવર ડાયામીટર રિક્વાયરમેન્ટ ઇઝ લેસ ધેન ઓર ઇક્વલ ટુ 6 મીટર 6 ઇંચ કરતાં ઓછી હોય અથવા તો હાઈલી કોરોઝિવ ઓપરેશન હોય ત્યારે શું કરવામાં આવે છે અને હેન્ડલિંગ ઓફ લિક્વિડ ત્યારે પેક ટાવરનો યુઝ થાય છે અને નોર્મલ અથવા તો હાઈ પ્રેશરાઇઝ માટે લિક્વિડ અને વોલ્યુમ રેશિયો કંટ્રોલ કરવાનો હોય ત્યારે ટ્રે ટાવર નોર્મલી યુઝ થતું હોય છે. In refinery where multiple rows and intermediate cooling requires, tray towers are widely used. Okay, so tray tower are widely used. All of you are familiar with different types of packing material and different types of tray usually used in the distillation. We know that the different types of agitations, different types of tray are available, and different types of packing material also be available. Mechanical design point of view, distillation column, absorption column, strippers, tray tower and pack tower type extractor. Tray tower and pack tower type reactors extractor are the same and are known as a vertical tall towers. मैकेनिकल पॉइंट ऑफ व्यू पर देखेंगे डिस्टिलेशन कॉलम को, एब्जॉर्प्शन टावर को, स्टिपर्स को, ट्रे टावर को एंड पेक टावर को. Tray tower and pack tower type reactors are same and all are known as a vertical tall towers. It has been estimated there are approximately 1 lakh columns or vertical tall tower in the world. Approximate diameters of vertical tall tower are in the range of 6 inch to 50 inch, that is 150 mm to 15 meter, and height of the same are in the range of 10 feet to 350 feet. If distillation column is to be operated at higher pressure or to be operated under vacuum, if distillation column is to be operated higher pressure services or to be operated under vacuum, the permanent hall must be provided in the skirt shell. Because of this permanent hall, atmospheric pressure is maintained inside the skirt shell, and skirt shell is not designed either for internal pressure or for external pressure. Now, the determination of cell thickness for distillation or absorptions or stripping column. At the top of column, only circumferential stress and longitudinal stress or axial stress due to the internal pressure or vacuum are significant. વેસલના ટોપ પર સર્કમફેરન્શિયલ સ્ટ્રેસ લાગવાના લીધે અથવા લોંગિટ્યુડાઇનલ સ્ટ્રેસ અથવા તો એક્સિયલ સ્ટ્રેસના લીધે internal pressure or vacuum are significant. If distillation column is operated under the internal pressure, then thickness of shell at the top of the column is finding out by these equations. Ts that means cell of thickness, P into Ri divided by Fj 0.6 P plus Ca. In case of diameter is given, then tau s Pdi is divided by 2Fj minus P plus Ca. So this one is standard method for the ASME code and BS 5500 code. If the distillation column is operated under vacuum, same method is used for finding out the thickness of distillation column. જ્યારે વેક્યુમ કોલમ હોય ત્યારે આ જ મેથડ યુઝ કરવામાં આવે છે. That we used for cylindrical cell subjected to external pressure. Assume that thickness of cell is T. Find out the ratio of L by D0 and D0 by T. Then from factor A gives factor B. Design external pressure PD. 1 atmospheric is the maximum pressure. Should be less than or equal to the maximum allowable external pressure. The thickness may be satisfactory up to a certain distance from the top of the shell. Let this thickness can be used to a distance x from the top of the shell. In addition to circumferential stress, other stress induced in the cell in axial direction. So stress axial direction or longitudinal stress induced to the internal pressure. FAP is equal to PDI upon 4 Ts minus C. This stress remains constant throughout the height. Second is that compressive stress created by dead load in axial direction. Compressive stress by weight of shell at a distance x from the top of the shell. This one is given by F of ds, which is weight of shell up to distance into distance x up divided by correction sections of shell. So it is F of ds pi by 4 d0 square minus di square into rho s x g by gc divided by pi dm ts minus c, approximately rho s g by gc into x. dm is mean diameter shell, cell. d0 by di outside or inside diameter of shell. Rho s is the density of the shell plate material. F. Compressive stress due to the weight of insulation at distance x from the top of the shell. F. Dings pi dins, tins, rhoins, and x gs by g by gc. So similarly, compressive stress created by liquid in the column. So liquid is supported by trays and tray are supported by shell. Okay, so the trays are supported by the shell plate. Now the next is that support for the vertical tool tower. A vertical tool tower હોય તો એનો સપોર્ટ કઈ રીતે આપણે આપી શકીએ? So NPSH, that is net positive suction head. So vertical tool tower having an internal diameter is either di is greater than 600 mm. Vertical toll tower, it is having the diameter is greater than 600 mm, are usually mounted on the skirt support. If the diameter is less than 600 mm, then column are supported on the leg support. The skirt height is decided by NPSH required by the bottom product pump. NPSH is given by the pressure plus or minus H minus friction loss minus vapor pressure, where P friction loss and vapor are expressed in the height of process liquid. P is operating pressure above the liquid surface at solution in millimeter into liquid column. H is the vertical distance between liquid surface at the source and center line of pump. NPS should not be less than 2 से लेके 3 meter, in between 2 to 3 meter. Skirt height is generally kept about the 2.5 meter. Here is the given, right hand side is the skirt support, which is including the bottom of the part, bearing plate, skirts, compression ring, gusset plate, bearing plate, strap, and then the shell. Okay, so you have to remember that skirt height is usually kept about the 2.5 meter. Skirt either having a straight cylindrical or angular cylindrical shape is either welded to outside surface of shell or welded to outside surface of head. Bottom of the skirt is welded to bearing plate, and hence the column load is transferred through the skirt to the bearing plate, and through bearing plate it is transferred to the concrete slab. Bearing plates are two types: angle bearing plates and the ring bearing plates. Okay, so at the end or the bottom of the plate, it will be the two types of plates. So that is angle bearing plates and ring bearing plates. Stress created in the cylindrical shell or skirt are due to the dead weight of the column and its attachment, due to the wind load and due to the seismic load. So let's see this. Due to the dead weight, stress created in the shell plate of the skirt. So this one is F of D, summation of W, which is the dead weight, divided by pi d0 k t of sk. बराबर. તો જ્યારે ડેડ લોડ કેલ્ક્યુલેટ કરવાનું હોય ત્યારે સ્કર્ટ સપોર્ટની અંદર આ ઇક્વેશનથી કરી શકાય. Summation W, it is a dead load, dead weight of column and its attachment. D0 of K is outer diameter of skirt and TSK is the thickness of shell plate for the skirt.